Okay, number 11 is a very familiar series, and what that series is e to the x, which you probably should know. I will say this, though, it is easy to forget things, and if you do forget something, you might want to have to rederive it. So let's put this over here. F of x equals e to the x. And I'm going to say you probably know the series as being, 1 plus x squared over 2 factorial plus x cubed over 3 factorial, yada, yada, yada. And this is true for all real numbers. Now, if you write that down as a sum, let's do that now. I'm going to say n equals 0 off to infinity. And then I'm going to say x to the n over n factorial. And again, this is true for all real numbers. So if you were to write down the radius for that, the radius would be infinity, and the interval would be from minus infinity to infinity. All right, so my suspicion, if the question's been asked, we're being asked to derive it using techniques that we know about. So what I'm going to do is write derivatives down. And what's nice about this guy over here is, f of x is e to the x, and every single derivative after that is also the same thing. I mean, every single one. I mean, you could do this the rest of your life, and it's never going to change from e to the x to e to the x. All right, so the nth derivative of this thing over here, yada, 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 the nth derivative is just going to be e to the x. What makes this convenient for us is we can evaluate this thing, especially at the point they're giving us, which is evaluated at a equals 0. I'm going to put this over here. What do you get over here? You get f of 0. Well, that's 1. F prime at 0. Well, that's 1. F double prime at 0. That's 1. F triple prime at 0. That's 1. Yada, yada, yada. And the nth derivative at 0 is also going to be equal to 1. So I'm ready to write down this over here using the Taylor expansion centered at 0. And what are you going to get over here? Well, again, f of x is equal to e to the x. If we do the Taylor expansion, f of 0 is 1, then we're going to get what? Let's see. We're going to get f prime at 1, which is 1, divided by 1 factorial. And then what do you get there? You get x to the first power. Let's do the next one. It's going to be 1 divided by 2 factorial x squared. What's the next one going to be? 1 divided by 3 factorial x cubed. Yada, 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 yada. Let's write this down. Looks like a sum. N equals 0 off to infinity. I'm going to say it looks like factorials on the bottom. What do I mean by that? This is 0 factorial. There's certainly a 1 there, but I'm looking at the x's. I'm going to say it just looks like the powers of x. x0, x1, x2, blah, blah, blah. What do I do now? Ratio test. Let's write that down. Limit as n goes to infinity, x to the n plus 1 over n plus 1 factorial. We're going to multiply by the reciprocal, n factorial over x to the n. Let's evaluate that limit. Limit n goes to infinity. Well, it's going to be the absolute value of x over, let's see, n factorial would cancel, and you'd be left off with n plus 1. And what's this limit going to produce? 0 for all finite x. So what could x be? Any number between infinity and minus infinity. What's the radius over here? The radius is infinity. What's the interval going to be? From minus infinity to infinity. And that's end of story. How do we derive that? We use Taylor's expansion to do that, centered at 0. Thank you.